Today I'm going to give you a jump start on some of the most commonly used Observatory.net API calls so you can start being productive as quickly as possible. When you downloaded Observatory, you had these two folders, build and example source code. This time let's go into example source code, and there's a examples.sln solution file. Go ahead and open that. I've already done that here. And when you open it, you'll see you have one project called examples, and it references a bunch of things including Observatory lib. And basically we have a set of scripts. Each one of these will run a different example. So first one, let's look at Hello World 3D. And in here I've basically commented out everything except for these two lines. So when I run the program and select this Hello World, it's going to make a new plot and display it. When you make a new plot, the plot is empty, the labels are empty, so it's pretty boring. But let's just run that real quickly and see what that does. So here's the program. Hello World 3D is the script we want. Run this. Here we have our empty plot. Okay, great. Now what I want to do is show you how to add some actual data to that plot, and the simplest form of that is this add points, lines, and triangles method. This method is right down here, and what we're doing here is we're making a drawing builder 3, which is a class that helps us add points, lines, triangles, remove them to a drawing that is composed of those three things: points, lines, and triangles ultimately. And there's a bunch of convenience methods. You can add quads and hexagons and things like that. But essentially all we have to do is create a new drawing builder, add, for example, add a point. Here we're specifying the XYZ coordinate of the point as 5, 6, 7, and the color is blue. And we're going to add a line that goes from this point to this point. That's going to be a red line. We're going to add a triangle. The triangle is defined by these 3 points. They make they're all aligned to plane by definition, and that triangle is going to be green. So the essential things to notice here are: you make a drawing builder, you add stuff to it, and then you add the drawing to the plot. Okay, and this plot is the one up here that we're going to display. All right, so let's just run that. Very simple, and see what we see. And here it is. As expected, we have our one blue point at 5, 6, 7. We have our one red line, and we have our one green triangle. Okay, and you can zoom around and see that they're there. All right. Next thing I want to show you, I won't go into detail about this, but I'm going to switch the method to add these point clouds to the plot just because they kind of look nicer, and they illustrate a different version of a different overload to adding points. So if you read the code here and jump in, you'll see when I add a point cloud, I'm basically generating randomly generating normally distributed values and using this add points method on a different drawing builder where I'm adding the X, Y, and Z components as well as a color. So let's just switch that so you can see what that is. Alright, and it looks like this. We got a whole bunch of points, and each one of these clouds has 10,000 points. Alright. So let's leave that there. Next thing I want to do is let's move the display method down. Down. Actually, here, I'll get rid of this display method and I'll use this display method. This is basically the same thing, except I'm specifying a resolution for the plot. So for example, in this case, it's a resolution that's 720p, which is a 16:9 aspect ratio. So same thing, gonna run this again, and now you got your plot at a standard size. So actually, if you save a screenshot, this should be 720p. The window itself is a little bit larger because of these little borders here on windows that are added on. But there are a bunch of different options that you can use here, and you can find something standard that works for whatever it is you're trying to visualize. Okay, so now I want to show you there's just a bunch of basic methods in here. Look at something like on the plot. There's something called plot.axes, and that has a whole bunch of useful methods in it. You can change the colors, put grid lines and labels and things like that. Other settings as well. Most commonly used, maybe set labels, XYZ. You can choose whatever labels you want, obviously. So let's turn that on, and then I also want to let's do two things at once here. So let's add also on plot.axes, there's this set scale equality method, which if you watch the video on interactivity in 3D, I explain a little bit what set scale equality is. By setting this true, basically what we're doing is we're fixing the space that we're visualizing such that a right angle truly is a right angle, and a sphere really is a sphere. It's not stretched in any one way. The dimensions are basically showing the same scale in terms of pixels to whatever the units are on that axis. So let's run it like this again, and you'll see when we run, we have the plot is automatically adjusted for us, so that now we are actually seeing, true scale equality. So these, in fact, these two things are spheres, and when we weren't scale equal, they looked kind of like pancakes. Okay, another useful thing you can do, I'll turn that off, and I'll show you a variety or a variant on that, which is we can set scale equality, but only on the x and y axes, and leave the z to vary freely. This is very common. For example, if you're looking at essentially a height map of some kind where the z-axis is very, very tiny compared to the size of xy, and you still want to be able to see the xy in relative to each other, in correct proportions, but you want to exaggerate the z, for example, to see what's going on if you're looking for a subtle effect. So let's take a look at that. It should be pretty self-explanatory. Here it's fixed the x and y to each other, but z is allowed to stretch to fill the space. And so in fact, if I try and expand along z, it lets me do that without affecting the others. If I try and expand along x, it's going to expand the y as well. Okay, to keep that, again, it's trying to maintain the x and y scale equality here. All right. Last thing I want to show you for now is you have the ability when you display, there's an optional parameter called weight. And if weight is true, which it is by default, then this display method will block this thread until the plot has displayed and rendered its first frame. After that, control continues on this thread, and you can interact with the plot after it's been displayed. And you still have a reference to it, here, obviously. So what I'm going to do, just to demo that really quickly, let's put in a thread.sleep, 3 seconds, and then after those 3 seconds, I'm just going to change the x-axis label to something else. And you don't need to do this in any special thread. I could do this, in a separate thread, however I want. I'm not going to break anything. Observatory internally will handle making sure that it doesn't jump in the middle of a frame and cause something to be corrupted or whatever like that. So I try to take care of all that stuff for you. So let's just run this one last thing, see what it does. All right, here we are, display. Let's let 3 seconds go by, and then boom, axis updates as you expected. All right, that's it for now. Thanks.